Okay, let's talk a little bit about B-axis turning. So we'll do a file open, part 9, B-axis turning. First you want to make sure that you have a MDD that's representative of a machine that can do B-axis turning. In this case, we're just using a demo machine. We'll open up our tools in our CAM. We'll bring down our tool, we'll bring over contouring. B-axis resides in contouring. Now, if we were just going to use that tool to contour this part, we would select the geometry as normal, say do it, and the toolpath would come along, but because we're gouge checking the back edge of the tool, we'd have to have a subsequent process to come back here and clean this out. Now with B-axis, if we switch on B-axis, we'll switch on vary the B-axis and we'll keep it normal to the drive curve. The drive curve being the geometry. And we'll do smooth normals, which means every time it reaches a normal vector, it will just make a nice smooth transition. I'll just redo that, and now you can see how nice the toolpath moves along that part. We'll go to our CPR, and you'll be able to see how nice the tool moves along, cleans everything up very easily. The other thing we can do is use a guide curve. So you have this guide curve, and then you have the curve that we want to cut. The guide curve and the drive curve must have the same amount of elements. So one cannot have 10 and the other one have 3. They have to have exactly the same. So let's go back to our B-axis, and we're going to select guide curve. Now what we have to do here is actually select the guide curve. So we'll pick select. We'll double click. That is our guide curve. As it turns green, we'll say OK to that. Again, we can pick the driving curve or the geometry that we are going to cut, and we'll redo that. Now the toolpath, actually the normal vector of the insert, is being driven along this guide curve. Now in this case it looks about the same, the toolpath. So that's how we can use a guide curve. You can also use vectors. These vectors were created and trimmed, which is what you have to do, and you have to go from the inside out. So using terminated vectors, what we do is basically the same way we do it with a guide curve. We would select the vectors, so we'll just go with selected vectors. We can hold down the control key, pick the vectors, and say OK to that. In this case we have some choices how you want to transition from one vector to the next. Preceding feature only, which means that the one preceding is the one that it's going to use. It's not going to do what we call multiple feature, so it goes around and follows all the vectors exactly. So then I'll select the geometry that I would like to cut, and we'll redo that. And now what you'll see here, and we'll single step through this, is the center of the insert is the center line of the vector, and it lines up with the vector line that we have there. So as it goes around, it's going to transition, and again it lines up. So that's how we control the insert vector using vector lines. There are more options here in B-axis turning. You can set the minimum and maximum angle. So if you have a tool that doesn't exactly fit and it's going to gouge on the front or the back, you can actually set the minimum or maximum angle so you can control the angle of movement. You can also control the lead and the lag angle, again controlling how it's going to come in, move around the part. We're also interpreting the vector as the insert vector. And again, the insert vector runs right down the center of the insert. You can do it by diameter vector or by face vector. So a diameter vector runs horizontally, and a face vector runs vertically, and you will get dramatically different tool paths based on that. And those choices reside underneath the insert vector. So set up by diameter vector, again horizontally. This is used mostly for doing some ID work, or by setting up the face. So there you have B-axis turning